So in this whole module, this topic on probability, we've kind of been building up experimental probability, theoretical probability, um, writing our sample space, now using a tree diagram to write our sample space. But again, we're still trying to figure out what is the probability of something occurring. So let's kind of put it all together, this whole tree diagram from the start and finding probabilities. So two friends meet at a grocery store and remark that a neighboring family just welcomed their second child. It turns out that both children in this family are girls and they are not twins. One of the friends is curious about what the chances are of having two girls in a family's first two births. Excuse me. Suppose that for each birth, the probability of a boy birth is 0.5. So the probability of it being a boy is 50%. The probability of it being a girl is also 50%. Okay, so we're going with either be born a boy or a girl. So draw a tree diagram demonstrating the four possible birth outcomes for a family with two children, no twins. Use B for boy and G for girl. Consider the first birth to be the first stage. Okay, so here's again, like how do you get started, right? First birth, so you have your firstborn, start there. Okay, don't try to think of it all at the same time. Okay, firstborn. Well, at a firstborn, what are the two outcomes could be? The baby could be a boy or the baby could be a girl. Notice I always leave some space, right? So always just stop there. Okay, don't try to, people try to combine things, right? Firstborn and then secondborn, right? Some of you might be the oldest. Okay, maybe some of you are the second, maybe some of you are the third, or so on. Okay, but someone was born first, not twins, remember, and someone is born second. So secondborn. Okay, and secondborn. Now this is where we start connecting it. Look at the firstborn. Let's say the firstborn was a boy. The secondborn then could either still be a boy. Shouldn't put these so far apart, sorry. Or it could be a girl. But if the firstborn was a girl, well, the secondborn could still be a boy or a girl. Okay, again, try to space them out a little bit. Doesn't matter if you put girl then boy, absolutely not. Okay, as long as you got them all covered. Which means our outcomes are boy boy, boy girl, girl boy, or girl girl. All right, so that is how we set up our tree diagram. Really very careful. What am I looking for first? And then once I have the first thing, draw your branches off of each of those. We could have three things here, not being boring, but you know, they talk a lot of times they'll do it with like pizza toppings, right? You have to select what type of crust, and then off the what type of crust, you know, maybe what kind of toppings and any of that stuff. So it doesn't just have to be two, that's just what we're practicing with right now. Okay? Now, the second part says write in the probabilities of each stage outcome. Okay? So probabilities. So a boy is 0.5. So again, underneath it, 0.5. A girl is 0.5. Now you go that over here. What is the probability of a boy it being a boy? 0.5. Probability of being a girl, 0.5. Probability of being a boy, 0.5. And a girl is 0.5. Where am I getting that information from? It's right up here in the directions, okay? Now, if we want to find the outcomes, remember, we're still inside the tree diagram. And if we're inside the tree diagram, that's when we multiply, okay? So you take these two here, this boy first, boy second, and we just multiply. 0.5 times 0.5 and we get 0.25. So we take this right here, and guess what? They're all going to be, right? 0.5 times 0.5. Probably not the best example I could have chosen, but the setup and the numbers, if you just put in those numbers, then all you're doing is you're multiplying the lines, right? The branches, since it's a tree diagram. Sorry, that's a 5 there. And the last one, girl, girl. Inside the tree diagram, we multiply. Okay? All right, so now we have the probability of having a boy then a boy then a girl then a boy, or a girl then a girl.
So the last problem here says, what is the probability of a family having two girls in the situation? Is it greater than or less than the probability of having exactly one girl? So now let's see kind of the both things. Probability of having two girls. So probability of two girls. Go up here to your outcomes. Our outcomes, there's 4 different outcomes, okay? We are interested in GG. Okay, so this right here would be G and G. What is the probability of GG? 0.25, right here. Now, it wants to know, is that greater than or less than the probability of having exactly one girl? Okay, so the probability of exactly one girl, okay, that's the number 1 there. Well, if we look at our 4 outcomes, which one are they? Exactly one girl there, and exactly one girl here. So we have 2 outcomes, okay? We could either have boy then girl or girl then boy. We're outside the tree diagram right now, okay? Exactly one girl. We'd have this or this. Either one, right, is exactly one girl. Remember, when you see that word or you have 2 things outside the tree diagram, that's when we add them. So this would be 0.25 plus 0.25, which would give us 0.50. Okay, so you can leave it like this, or if you want to make it into percent. So you could say like this is a 25% chance of having 2 girls. It's a 50% chance of having exactly one girl. Okay, so just to kind of sum things up here, when we're done, tree diagrams are useful to organize outcomes because we can see the outcomes. I can see the different types of, birth order. They're performed in multiple stages. Stage 1, stop there, and then off of each stage 1, you can do stage 2. And they're useful for computing probabilities events with more than one outcome as well.